Next topic in calculus is limits. What does limit means? You might have seen limit in a normal sense, but limit in calculus is not that, which you already know, not the meaning of limit. Limit in calculus means approaching. There are many different ways of approaching, right? But here limit means approaching something. So whenever you are hearing a word limit in calculus, it means approaching. Simply remember this. I will give you the meaning, why approaching, what is that, all those things I will give. Limits means approaching. How that I will say. So for example, there are something which you cannot find out directly. You can see this example which I given you, famous example for limits. If I substitute x is equal to 1 here, what happens? If I substitute x1 here, my f of 1, wherever x is there, I need to substitute 1. So 1 square minus 1 by 1 minus 1, which is equal to 0 by 0, which is obviously undefined, indeterminate, which we don't know what the value is. We cannot find the value of f of x when x is equal to 1. We cannot find it directly by substituting x equal to 1 here. I cannot find the value for f of x, right? That is the situation when we need to approach it. Instead of directly finding the value for f of x at x equal to 1, we need to approach this x near the value of 1. We need to approach this value 1 closer and closer. Instead of directly substituting this 1 here, we need to substitute some value which is very closer to 1. We need to approach the 1. For example, I given an example here, the same example I did it in the case of limits method. What I did here, initially I taken x equal to 0.5, and when I substitute 0.5 in our equation f of x equal to x square minus 1 by x minus 1, I am getting 1.5. If I substitute 0.9 in our equation, I am getting 1.9, and I am now approaching closer. Initially 1 is my value. I am approaching from 0.5 to 1. From 0.5 I reached 0.9. Now from 0.9 I am reaching 0.99. I am approaching closer and closer to 1. 1 is my final destination, but if I directly substitute 1 here, I am getting 0 by 0, which is nothing but indeterminate, undefined, right? Instead of directly substituting the 1, I am approaching the 1 from some other value. From 0.5 I am approaching 1. So now I approached 0.9. From 0.9 I reached 0.0, 0.99, and if I substitute 0.99 here, I am getting 1.99. And if I substitute 0.999, which is I am approaching closer. Obviously you know 0.999 is very closer to 1, and 0.9999 is much more closer than 1. If I keep on doing this, if I keep on approaching 1, what is happening to my f of x value? As x approaches to 1, as x keep on approaching to 1, my f of x is approaching to what? 1.5, 1.9, 1.99, 1.999, 1.9999, which means my f of x is approaching to some value. That value is 2, right? 1.999 and 1.999 is what? 2, approximately equal to 2. So when x approaches 1, when x approaches from some other value, here my x is approaching from 0.5 to 1, at the same time my f of x is approaching 1.5 to 2. So this is my limit. This is my limit of 1. Limit of f of x at x is equal to 1. We cannot say that 2 is the exact value of f of x when x is equal to 1. But 2 is the limit, 2 is the value which f of x approaches when x approaches to 1. Say it in a simple manner, what is the value of f of x, or in other sense, when x approaches to 1, what does f of x approaches to? That is my limit. So in this case what I did, I am approaching this 1 from 0.5. So if I approaches x from 0.5 to 1, my f of x is approaching from 1.5 to 2. In the same case, if I try to plot this x in a number system in a line segment, what happens? 0, 1, 2, minus 1, 3. I can plot it like this, right? What I am doing here, I am approaching from 0.5 to 1, which means somewhere here will be the 0.5, between 0, 1, 1 will be the 0.5, and from 0.5 I am approaching to 1. From 0.5 I am keep on increasing the value so that I am checking how f of x is changing. If I keep on increases x value until 1, how f of x is changing. That is what I am doing here. I am doing it from left side of the 1, right? Left side of my x value. So from left side I am approaching to 1. Same way I could do from right side too, right? For example, I could take 1.5, 1.6, 1.9, 1.999. I could do, I'm sorry, 1.5, 1.4, 1.3, something 1.01, 1.001. I could do. From right hand side also I could approach. From right hand side also I could approach to 1. Right? Instead of approaching from left side, I could do from right hand side also. So even if I approach from left hand side and also if I approach from right hand side, when I am doing both the cases, my value of f of x should be same. If my value of f of x is same when I am approaching from both left and right hand side, then only we can say that limit exists. We will see how for this example what is happening. Then we will decide. We will define the limit in a definite manner. So now we can do the both examples, both side, left hand side limit and right hand side. We can approach. Now we will see that example by approaching from both side, from left hand side and from right hand side. So now you can see here what I did. I did the same like what we seen in the last case, in the last example, in the same example in the last slide. 0.5. If I substitute 0.5 in x, I am getting 1.5, and from 0.5 I am reaching 0.9, and 0.9 I am reaching 0.99, and from 0.99 I am reaching 0.999, and if I keep on continuing I will be reaching 1. That is, I am approaching 1 from 0.5 to 1, right? So I am approaching, x value is approaching towards 1. If x value approaches towards 1, how this f of x value is varying? You could see 1.5, 1.99, 1.999, 1.9999, which means the value of f of x is approaching towards 2. If x approaches towards 1, my f of x value is approaching towards 2. So then I said then 2 is my limit. Limit of f of x is nothing. F of x when x tends to 1 is 2. That is what I said. But this is only one half, because we approached towards 1 only from one side, right? If I draw a number system 0, 1 and 2, I approached from left side. I had not yet approached from right side. From 0.5 approach, but I didn't approach from right hand side, right? So now I am doing for here. What is happening here? There is 1.5, 1.1, 1.01, 1.001 and 1.0001, which means from 1.5 I am approaching towards 1. My x value is approaching towards 1 from right hand side. This 1.5 is where? 1.5 is somewhere here. So this is from left side, this is from right side. So now from right side I am approaching towards 1. What is happening to my f of x? Initially it was 2.5, 2.1, 2.01, 2.001, 2.0001, and if I keep on increasing, my f of x is also approaching towards 2. So what is happening here? If I approach x value near to 1, closer and closer to 1, from left side I am getting f of x is approaching towards 2. Same way, if I approach to 1, closer and closer to 1, from right side, that time also I am getting f of x, I am approaching f of x closer to 2. So both times, if I approach x value closer to 1, I am getting f of x closer to 2. So that is what we call it as limit. When both this condition, when we approach from left hand side, when we become closer and closer to x, when we become closer and closer to x, we will get one value. That f of x also will become closer and closer to some value. Same way, when we become closer and closer to x value, this f of x will also become closer and close to some other value. And these two values, this value and that value, should be same. If both of the values are same, then we will call that limit exists. That is, if I approach from left side and also if I approach from right side, when if I approach both the side, both time our limit should be same. And this limit is called as left hand side limit or left side limit. So left side limit and right side limit. Left hand side limit and right hand side limit, both should be same. If both are same, then we can consider that limit exists. If both are not same, then we cannot say that limit exists. So points to remember is, limits are nothing but the value of f of x when, or we can say what is the value of f of x when x becomes closer and closer to its original value. When x approaches to 1, what is the approachment of f of x? Simple. Either from left hand side and right hand side, even whichever side you are approaching. That is a simple definition for limit. We will see the exact what are all the conditions for limit. So we seen what is limit is. So just I am going to give you the conditions for limit. So generally limit will be specified by this, either limit x tends to a or lim or lt x tends to a. So how to read this is, when limit x tends to a, f of x. Limit x tends to a, f of x. So what does this symbol means? Approachment of f of x value when x approaches to a. What is the value of f of x? What is the value of f of x we are getting when x approaching to a? That is the meaning. So when we can consider that for some particular function, when we can say that the limit exists, only if the left hand side limit and the right hand side limit are same. So left hand side limit are generally specified by using x tends to a minus. The value a is nothing but 1, 2 or 3, whatever value may be. So x tends to a minus is specified by using left hand side limit, and right hand side limit is by using x tends to a plus. And if this left hand side and right hand side limit are satisfied, that is both of them are same, then we can say that limit exists. So what happens if both of them are not same? We will see one example such that the both of them are not same. We will see an example on limit x tends to 0, and this is my function 1 by x. So limit x tends to 0, 1 by x equal to what? That is what our example is. This you could easily find. This is nothing but rectangular hyperbola. 1 by x function, it is a rectangular hyperbola when f of x tends to x. You would have seen some f of x y. Rectangular hyperbola's equation is x into y equal to constant. So y is equal to constant by x. So in this case my constant is 1. So it's an equation of rectangular hyperbola. So what is happening here? When x tends to 0, what does this 1 by x is going to do? So what we need to do, we need to find both the cases. One is left hand side limit, x tends to 0 minus 1 by x, which is nothing but we are going to approach from left hand side. So 0 is 0 present here, right? So when I move from left hand side in x axis, how f of x is varying? F of x is keep on increasing. As my x keep on approaching to 0, this f of x also keep on approaching to, it is keep on going down, nothing but it is a negative side, it is a positive side. So this f of x is the function is keep on going towards negative infinity, right? So here when my x approaches towards when my x approaches towards 0, my f of x is keep on increasing in negative y direction and finally it will reach negative infinity. So when x approaches to 0 from left side, that is what I specified here, 0 minus means left hand side limit. So left hand side limit, when x approaches to 0 from left side, my function 1 by x is approaching towards minus infinity. So my limit value is minus infinity. So in the same way, limit x tends to 0 plus 1 by x equal to what? When my x approaches towards 0 from right hand side, I am approaching towards 0 from my right hand side. From right hand side I am approaching towards 0. Then what is happening to my f of x? My f of x is keep on increasing, keep on increasing, keep on increasing, and it will keep on go. It will keep on go upward. So initially when I approach x value from left hand side, my f of x keep on going downwards. So positively it will go to negative infinity. But here now if I keep on approaching from right hand side, my f of x value keep on increasing in positive y-axis, right? So which means when I approach x from right hand side, which is nothing but right hand limit, my 1 by x will approach us towards infinity. So in this case, left hand limit is not equal to right hand limit. So obviously for this function limit doesn't exist. So it's a simple theory. Limit exists when left hand limit and right hand limit are same. If both of them are not same, then limit doesn't exist. So there is no need for doing all this stuff in your gate examination. There is a simple rule called as L'Hospital rule. Either sometimes they will call it as L'Hospital rule or L'Hopital rule, whatever. It's your pronunciation. It is a French word. I also don't know the exact pronunciation. So it is This is the exact spelling, but I don't know the exact pronunciation. Just by using this rule, you can easily solve whatever problems they are giving in the gate. So these concepts which we discussed also very much essential. They will test you sometimes in those concepts which we discussed. Sometimes directly by using a L'Hospital rule you can find it. So both concepts and L'Hospital rule both are essential for understanding the limits clearly. And some standard results are there. Some standard results for limit. Those values you need to remember. We will discuss one by one the standard results, and first we will go to L'Hospital rule, then we will go for the standard results, and we will discuss few problems in limits.